Hello friends, today I'm going to solve LeetCode problem number 852, pick index in a mountain array. We are given an array of mountain. The length of the array is at least equals to 3 and we have an index I such that the value of the array keeps on increasing until we reach the index I, and from index I it starts decreasing, which means that we are actually forming a shape like a mountain like this. So the value keeps on increasing from index 0 until we reach index I, and then from index I it starts decreasing. So we are forming a mountain, and here we need to find that index I in logarithmic time complexity. So how can we actually solve this problem in logarithmic time complexity? So let's look at this example here. So what are we given is we are given an array, and here our index I, which is the peak of the mountain, is this, that is it lies at index 1. So we can see that there exists a sequence here. The sequence is that it starts increasing from 0 to the index I, and it's decreasing from index I to 1, right? As I already told you, like it's increasing and then decreasing until the last index, right? So what does that mean? This means that since it has some kind of order, we can use binary search to solve this problem. So binary search means that we can solve it in logarithmic time complexity. So how can we apply binary search to this problem? So let's just look at the intuition behind that. So we are going to start taking a left and right index. Okay, let's suppose that this is some kind of mountain, that is the array that we are given, and left and right. Okay, now we need to find the middle index. Let's suppose that our middle index is somewhere right here, which means at this point. Now this is our middle value, and now we compare our middle value with the next value to it, that is the next index, which is m plus 1 index. Okay, so we are comparing this with m plus 1 index. So while we're comparing, we see that m plus 1 is greater than m because it's increasing, right? So here index value at index m is less than m plus 1. So since it is increasing, what does that mean is that our peak still lies towards the right, towards the right of the middle value, and our middle value can never be the peak. Why? Because we have a value which is greater than m, that is m plus 1. At least we have one value which is greater than m plus 1 that we know of. So our peak is never m, but it could be m plus 1. So what we do is we change our value of left index to be equals to m plus 1. Okay, now that we have shifted our left index to m plus 1, so okay, so if this is our left index, now our middlehood lies somewhere here, right? Now in this case we compare again our middle value with the next index, which is at index m plus 1. Now we see that index m plus 1 is less than m. So what happens when index m is greater than m plus 1? We will never have an index which is equal because it's either increasing or decreasing. So if index m plus 1 is less than index m, in that case we know that index m could be one of the possible peak values, right? So it could be something like we could have a mountain like this, but we do not know for sure, and we know that our peak lies somewhere towards the left of our mid value. So what we do is we shift our right pointer to equals to m, so that we also consider m. Now what is our area of calculation? Our space of calculation is from now left to right. Okay, so it has reduced by half. Now what we do is we again check the middle value. Now middle value is somewhere right here. Okay, and here again middle value is greater than its next index, because it's a decreasing sequence here, as you could see. So since the next value is less, what do? We take our right equals to m. Okay, so now our right is again equals to m. Okay, I'm just going to remove all of these. Okay, so now this becomes our right index. Okay, next our left middle value. So let's suppose our middle value is now passing right through the peak. Okay, but we still don't know for sure. Now what are we doing? We are again checking if our mid value is less than mid plus its next value or not. It is not less. Mid value is actually greater than its next value, right? Its next index, because it is the peak, it's the most. So mid is greatest of all of its index. So when mid is greater than the next the value at next index, that is what we do. We shift our right to be equals to mid, right? So now here again our right index changes to the mid. So now we have our right and our left and mid. Now once we again calculate mid, let's suppose now our mid is just passing through left. Let's suppose that we just have two values now that we are calculating. Okay, so our left mid is passing through left. Okay, so if mid and left are both equal, now we again compare. Mid is less now, right? So we increase the left to be equals to mid plus 1, and so on. And then finally what we reach is, we would actually reach a value where our left is equals to right. Left is equals to right, which is also equals to our mid value. Now in that case we have found our mid value, and that is what we will return, our mid, which is equals to the peak. So this is how we are actually going to solve this problem. So now let's try to write our code. So what are we going to do is, we first need to check for the edge cases. So the length should be at least equals to 3, and since it is guaranteeing that it will always be a mountain array, but just to be safe, let us always check for the edge cases. So array that length is less than 3, that is when we know that it's not a mountain, so we just return -1, which means that there doesn't exist any index. Okay, next what are we going to do is, we are going to create our left index, which is equals to 0, our right index, which will be the length of the array -1, and our mid value, which is, for now I will not calculate that. And now in our while loop, while left is less than right, we are going to perform our BFS. So we are going to calculate our mid value here. Mid will be the floor value of our left plus right divided by 2, and then we perform our comparison. If the value at mid is less than the value at mid plus 1, that is when we know that mid less than mid plus 1, we need to move towards the right. So left equals to mid plus 1. Okay, so left, that is when left is equals to mid plus 1. Else we don't need if case, because that would already mean that mid is greater than mid plus 1, and in that case right equals to mid. So else right is equals to mid. All right, so once we have done that, finally we are going to return our value, which will be at our left index, because I'm only taking here left is less than right. Okay, so that is when we return the value at left, because that is where our result will be stored. Okay, so now here we have our test cases, which have all passed. Let's try to submit this. Great, so we have submitted it, and we found that this is taking 79%. Okay, so talking about time complexity, since we are solving it using binary search, it is logarithmic time complexity and the space complexity is constant. Hope you liked my solution. Let me know in the comments down below. Thank you.